today we've entered the exponent rules highway again, and we're going to talk about the multiplication property of exponents. This is in chapter 8 of the book, section 3. It's in our unit 7, and it's the third thing we are doing in unit 7. And there's kind of an example on the little board here of this cartoon, where you can see the x to the 5th. There's the 5 factors of x times, here's the 3 factors of x, and if you look, 5, 3, there's a total of 8 factors of x. So today we're going to use that rule that I've kind of just shown you really quickly to simplify exponential expressions that involve multiplication. So let's just take a look at what I just mentioned, and let's start with numbers here. So if I start with 2 to the 3rd, 2 times 2 is 4 times 2 is 8, and 2 times 2 is 4. So 2 to the 3rd times 2 squared is 8 times 4 is 32. Let's look at it a different way. Let's take those 3 factors of 2. You'll see the color kind of helps you. And those 2 factors of 2. And do you see here 5 factors of 2, or 2 to the 5th? And if you take 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So with numbers, I hope I've just kind of proven to you that when you multiply common bases, you write the base and add the exponents. So 2 to the 5th. There are 2 mistakes that people make here. The first one is to multiply the exponents. But look, there's not 6 factors of 2, there are 5. And the second one is to put 4 to the 5th, to multiply those bases. And when you do that, you've added an extra factor of 2. So when multiplying common bases, write the base and add the exponents. So having said that, let me show you with variables. There's the 2 factors of n, and there's the 4 factors of n. And if you notice, 1, 2, 3, 4, 5, 6, there are 6 factors of n, not 8. So when you multiply common bases, you write the base and add the exponents. Now we're not going to have to keep writing those out anymore. I just wanted to give you that visual. So here is the rule. To multiply powers having the same base, you add the exponents. So back to an example here. 3 to the 5th times 3 to the 4th would be 3 to the 9th. Don't put a 9 here, and don't put a 20 there, okay? Write the common base, add the exponents. All right, now we're going to get our expressions going a little bit longer. So the first thing I notice is I've got C's, kind of an Oreo cookie here with the cream in between. I'm going to use the commutative property and change the order. See, I'm putting the C's together. And when I take C times C, common bases, add the exponents, I'll get C to the 6th, and the poor D to the 3rd didn't have anybody to join up with. And that's as simple as it's going to get. So here's kind of your turn. How about try number 1? Did you get 5 to the 11th? Now, if you put 5 to the 11th in the calculator, it's kind of a big, it's a big number. Exponents grow rapidly. If that's 2 to the 3rd or 5 to the 3rd, then you could simplify it. But if it's going to be a ginormous number, you can leave it as its power. Okay, common bases. When we multiply common bases, we write the base and add the exponents. Go ahead and do that one. Did you notice anything? When you did that, you should have gotten 8 to the 0 power, which is 1. Anything to the 0 is 1. So here comes our 0 exponent rule. We did one like this in the last, 2 videos ago, and we rewrote this and made this 8 to the 2nd over, and remember you reciprocate, and he would come down as 8 to the positive power 2. You got the same number, 8 to the 2nd over 8 to the 2nd, which would also be a way of getting to the 1. Ooh, a whole bunch of 7s here. All a common base. Write your common base and see what you get on this one. So it should be 7. Negative 3 plus 5 would be 2, plus 4 would be 6, and it's 7 to the 6th power. Like I said, the number one mistake is to put like 25 as the base. And then, of course, be really careful not to multiply the exponents. Okay, so now let's see what's going on here. I'm going to do the first one with you, and then I'm going to ask you to do the next two. So, we haven't talked about what happens if there's numbers in front. So it's really what you have here is a 2 times an n to the 5th times a 3 times the n to the negative 2. And you could kind of think of this, in changing the order. You've got 2 times 3. Well, 2 times 3 isn't going to change anytime soon. That is going to be 6. So we're going to multiply those coefficients. But when we have something raised, same base, raised to, exponents, I'm going to write that base. And when I'm multiplying, I add the exponents. So what we have just added to the mix here is if you have coefficients in the front, you continue to multiply them as always. Don't put a 5 here. Don't start adding that 2 times 3 is 5, okay? So those coefficients still get multiplied. You write the common base, and you add the exponents. I'm going to let you do number 5. So did you get 6? Because he's out in front. Times 1 would just be 6. And did you put n to the 6? Now this one was tricky because sometimes, because this guy has the invisible 1, people will gloss over him, not see him, and put a 5. But, if you find yourself doing that, put that 1 in. There's 2 plus 3 plus 1. There are 6 factors of the n. Okay, let's get a little more complicated. Try this one. 2 times negative 3 is negative 6 times 4 would be negative 24. 3 plus 2 is 5 plus negative 7 would give me an exponent of negative 2. So I have a negative 24 times y to the negative 2. We can't leave that negative exponent. He's going to have to go to the other place and become a positive exponent. So the 2 times negative 3 times 4 is your negative 24. You had a y to the negative 2, but it needs to reciprocate and become y to the positive 2. The negative 24 has an exponent, an indivisible exponent of 1. Don't move him as well. He stays in the numerator. So now let's move on and see, just keep practicing. In this particular case, I'm going to ask you, the video is going to stop, and I'm going to ask you to basically match the answers here. So you need to, of the answers over on the right, which one is the answer for each one. Okay, let's start with number 1. 5 times 2 is 10, and 10 times 3 is 30. So our number in front is going to be 30. Don't forget there is a 1 here. 1 plus 5 is 6, plus 7 is 13. Oh, my bad. This is a y. I go back. Let's take it back. Let's start again. 5 times 2 is 10, times 3 is 30. X to the first, x to the 7th, that would be x to the 8th, and then y to the 5th. Bingo, right here. Okay, let's see if I can keep my brain straight this time, okay? Do number 2, please. 6 times 5 is 30, times 1 is 30, times 1 is 30. So we have a 30 out in front again. X to the 2nd, x to the 4th would be x to the 6th. And y to the 1st times y to the 1st would be y to the 2nd. 30, x to the 6th, y to the 2nd. If you haven't done number 3, let's check that one. 2 times 5 is 10, times 1 is 10. X to the 5th, x to the 0, if we add them, we will get x to the 5th. And the y didn't have anybody to join up with. And there are the 3 answers, and that's what we should have had. More practice? So we're going to do these together. We're going to get some scientific notation going on down here as well, okay? So I want you to take a look at this one. So, a couple of them I'll have you do, or I'll have you continue, but let's start here. Notice that this time I have a plus here. So this is going to be a distributive property. Hey, Mrs. Woodruff, I've noticed we've never had a variable out in front when we've been doing distributive property. We've always distributed a number. Well, that's because we didn't know this exponent rule. So when we take 2a to the second and multiply it by this group, we're going to have to multiply the first term, 3a, by the 2a squared and the 5. So we're going to distribute the 2a squared. So first we're going to take 2 times 3, that's 6, and a to the second times a to the first would be a to the third, and we're going to write that down. Then we're going to put our plus, and we're going to take that 2a squared, sorry, let me get him over there. We're going to take that 2a squared and now multiply it by the 5. So 2 times 5 is 10, and the a squared had nobody to join up with. So now we can do distributive property. Oh, by the way, we can't combine these. They are not like terms. You can't make this like 17a. No, because in order to be like terms, they have to have the same variable and the same exponent. So this is like having 6 chocolate chip cookies and 10 oatmeal raisins. They're different. You can't combine them and make them 16 or something. So again, now when we have a variable, we're going to use this multiplication rule when we do the distributive property. And that's as far as you can go. All right, let's go on to the next one. I'm thinking that maybe you can do this one yourself. So do number 2. Okay, so I'm multiplying in the denominator a to the third times a to the negative 2. Common base, write it down, add the exponents. You should have 1 over a to the first, but don't forget to make that exponent of 1 the invisible 1. I think you can do number 3 too, so go ahead. Okay, so did you take 4 times 1 times 3? Do you have a coefficient of 12? And the a to the first times a to the fifth would give you a to the 1 plus 5, 6. And then c to the fourth times c to the negative 3. 4 plus negative 3 would be 1. Plus you have another c out here with a 1, c squared. You're going to notice I did the a's first. Generally speaking, we will put the variables in alphabetical order, so I tend to just do that automatically. Try the next one. So 2 times 3 would give you 6 for your coefficient. And when you add the exponents here, you get n to the negative 2. 6, n to the negative 2. No. Don't leave it that way. That n to the negative 2 has to reciprocate and become n to the positive 2, but the 6 will stay on top. So how did we do there? Okay, so finally, how do we do, why do we do scientific notation? Because it is so easy to multiply numbers in scientific notation rather than trying to multiply really big numbers. So when numbers are in, here we are, 2 numbers in proper scientific notations, watch how easy it is to multiply. To multiply scientific notation, multiply the numbers out in front. So 7 times 4 and write it down. You'll see that in a minute. Then put your multiplication sign and use the new rule on the 10 bases here, on the 2 powers of 10. Write your common base and add the exponents. So 7 times 4 would give me 28 times 10 to the 7th. Is everybody okay with that? So what mistake might people make? They might put the 100 here. No. Common bases, write the base, add the exponents. Now you're going to remember when we did scientific notation, we learned that this is not proper scientific notation. So when we multiplied, the number out in front is no longer the way we need it for proper scientific notation. So can you, remembering what we did in the last lesson, fix this? So that 28 had to become a 2.8. We took kind of out a power of 10, so we need to add a power of 10. And did you put 2.8 times 10 to the 8th? And from past years, That is the thing that kids forget to do when they're multiplying scientific notation. They'll write the 28 times 10 to the 7th, and they will forget to fix it. How about if you try this last one today? So 9 times 7 is 63. Write your x for multiplication. Write your base 10, and negative 6 plus negative 9 should have given you negative 15. Not in proper scientific notation. This needs to be 6.3. Again, I'm taking away a power of 10 in the front of the number. I need to put it in. I need to increase this by 1. Be careful with that negative exponent. Did you go the right direction? Negative 15 plus 1 is negative 14. 1 bigger than negative 15 is negative 14, not negative 16. So today the whole idea was about multiplying powers that have common bases. And we learned that when we do that, all we have to do is write the base and add the exponents. So that's what we're going to be practicing, but please realize that as we go through these exponent rules, we're going to bring along the ones we already learned. So we're going to still have the negative exponents right now. We're still going to see the 0 exponents right now. And then as we go forward, this multiplication exponent, multiplying exponents will go with us. So give it some practice. I'll see you in class soon. Have a great day, everybody.